A unified data approach. This is an important new requirement for digital projects. So extract the data from silos across the organization and bring it together in a unified, accessible form. Alan Friedman, Principal Technologist, and Ted Dunning, CTO for Esmeralda Data Fabric, both at HPE. They're here to talk us through the latest data unification infrastructure approaches. Welcome, Alan. Welcome, Ted.
Thank you. Hello.
Ted, if we look to organizations, they have many different systems that store data. And data silos, that's still one of the biggest hurdles for a solid, unified data approach. In previous discussions, you said adding another system is going to solve the problem. Can you explain this?
That sounds like going backwards, doesn't it? And really, just adding a new system won't help. The key is if you can add one and unify four so that you have a net decrease in the total number of systems that you have to administer. And that's the sort of thing that will really help with this cluster sprawl problem.
Alan, you were addressing that adding a data infrastructure can help solving the silo data challenge. Can you elaborate on this?
Yes, and I think building on what Ted said, the key is to not keep adding new systems. That is what leads to sprawl, but to transfer your system onto something, to a data infrastructure that is unifying, that handles many different types of applications, many different projects, makes that data available to multiple groups and multiple types of uses. And when you do that, you're doing the same thing, but the complexity decreases greatly. That simplification shows up in simplified workflows and simplified architectures. And one of the ways that you can see that come out, there are a number of capabilities that data infrastructure needs to have to actually unify systems. But just taking an example, a data infrastructure that has a very broad access, it's a multi-API data storage and management system so that many different types of applications and tools can use it. You can kind of do a little test. If you draw out a typical use case in your organization and you think of it both in terms of the number of steps in a workflow, and maybe many of those are copying data from one system to another because of incompatibility, and then you think about what would happen if you put it onto this sort of unified system, you actually have less physical different pieces. That's the architecture. You often literally have less steps in the workflow because many of those copying steps drop out because of the multi-API system where all the different applications can access that same data without having to constantly copy it out to another system. So that's just one example of simplification.
Yeah, Ellen, I think it's important to add that as you unify these systems, you also have to have multi-tenancy. And when you get that multi-tenancy, then you can not only drop out copy steps, but you can share data where you would have wanted to have copy steps with separated systems, largely because a lot of times groups will be processing data in very nearly the same ways. Whereas if they could share the same system, share the same infrastructure, they could actually share the same work product. And then you wouldn't have to maintain as many unique kinds of processing steps, not just eliminate copies, but eliminate entire contentful processing steps as well.
So you're not only simplifying the logistics, but you are encouraging collaboration. People have a more comprehensive view of data. You get rid of those silos, and partly because they trust the system. They trust it. The system administrators trust letting them use it together.
And then you start getting virtuous cycles where simpler systems are easier to understand, which leads to more sharing, which leads to more simplification.
Alan, each organization has many different systems, sometimes 10, 20, and I have seen even organizations that have 100 legacy systems that store data in a proprietary way. How can this type of data be unified from a total enterprise perspective?
Well, I'll take an initial stab at that. I think it is very important to assume that some of those legacy systems may go away. You may be replacing them with these modern systems and do things in a more scalable and efficient way. But many of those legacy systems, it's not just the difficulty of reworking them, is that they have value in themselves. They're doing things in a very efficient way. And so, again, a unifying data infrastructure should be accessible by both modern tools and legacy applications. That broad accessibility means that they can run side by side. And even where you have containerized and non-containerized applications, legacy applications, modern applications, all of that should be able to run basically together on the same system.
Yeah, and actually, we've seen this. We've seen COBOL programs running in a legacy environment, or old VAX VMS systems converting, or mainframe systems, all because of this multi API applicability. And then it's key that these old systems can not only continue to run, if they aren't broken, why fix them, but that they can interact effectively with new systems, that they can live in a multi-tenant world with systems, say, that are containerized or running under Kubernetes, new machine learning frameworks, and so on. You really need not just that they can both run, but they can interact, that they can use each other's data products.
Ted, to summarize the conversation and maybe make it more tangible, can you give an example from enterprises that move to a unified data platform?
Yeah, and well, there's lots and lots of them, but one that I find very interesting is a retailer. They started with a small cluster, a very small cluster, around 20 nodes. And back when they started, that was several years ago, each node didn't have a whole lot of data storage, so that wasn't even that big in terms of bytes. But very quickly, that system proved to be very stable. And so some other applications were moved over onto it just because it was easy to move them onto it and it was stable. And that then meant that several hundred nodes were repurposed and put into the goal of expanding that cluster and taking on a few more dozen applications. Ultimately, it became several thousand nodes in that cluster, and people kept moving more and more applications across. And the real reason that they did that is because they really enjoyed the stability. And as the system got bigger, it got more and more stable, because even the largest applications were now a small fraction of the total work. But the advantages of sharing, the advantages of having access to data sets and so on became larger and larger. So the pull to unify became larger and larger. And that was really one of the things that taught us that this idea of unification was at least as important as any other feature in the system. And that's not really a feature of us, it's a feature of the customer's use of a system, that the unification itself became an advantage.
And just a slight nuance on what Ted's saying, it occurs to me, we're talking about having a system, a data infrastructure that can support multi-tenancy and do that in a very reliable way. But part of that, you have to have that for this to work, but part of that is you cannot mandate, or you should not mandate, multi-tenancy. Tell people all use the same system. If they don't trust or they don't find it convenient, they don't find it works well, they'll still go off and build their own systems. You still have these sort of shadow systems or even shadow IT. So I think what you see in the kind of example Ted's describing is there's a natural flow toward multi-tenancy. If the system works well in that manner, people actually like it and they're drawn toward it.
You can't push them into it, but you can certainly pull them into it.
Many thanks, Alan, Ted. A great conversation. And thank you for bringing us up to date on unified data infrastructures. And for the audience, thank you for watching, and we're looking forward to seeing you next time.